Yeah, yeah, right. I know why you're here. You don't believe that a set of the natural number has the same size of the set of even number, isn't it? Strange. But you've been told, maybe at school, that they have the same size. You know what? You are right. They don't have the same size. And I'll explain to you where is the biggest mistakes that mathematicians are doing. Stay with me and follow my thoughts. Every single mathematician says that natural numbers and even numbers have the same size, as well as the naturals and the integers, the natural and the rationals. Let's suppose that the natural numbers are people and the even number are the man. Do we really believe that the set of men and women has the same size as the set of the only man? I know that the topic is more complex than this, and I want to tell you why they are wrong in the easiest way possible. Okay? Just follow me. These are all assumptions. Create a relation between the set of natural number and the set of even number, which is a subset of the natural numbers, and send an element of n through a function to p, which is to n. So we have a relationship between 1 and 2, 2 and 4, 3 and 6, 10 and 20, and all of these are bijection. And we can go on forever. But wait a minute. We know that P is a proper subset of n. This means that exists an element that we call x that belongs to n and it doesn't belong to P. So, they have the same size, but exists a natural number that doesn't belong to even numbers. There has to be something wrong or missing in this process. Where are these elements? The problem is that they are not treating the set of the even number as a subset of the naturals. If the original assumptions were true, the even numbers go to infinity independently from the naturals, and this is impossible. Imagine that these are the even numbers, and these are the natural numbers. The even numbers can't overtake the naturals while going to infinity. Okay? This is a limit. This is the limit, okay, of the even numbers. This means that these ones are a subset of the naturals, and these ones are the naturals. If I want to make a bijection between a natural number and an even number, I must wait until the natural arrives at the even number which satisfies the relationship. Otherwise, I cannot make any bijection. Remember that the even numbers are a subset of the naturals. Overtakes are not allowed. This representation of the bijection doesn't take into account that the even numbers are a subset of the naturals. This one instead follows this rule. Using this representation, it's clear that before making a bijection, I must wait till the natural numbers come to even numbers. That satisfies the function. If I have 4 numbers, I can make 2 bijections because there are only 2 even numbers. With 6 numbers, I can make 3 bijections, and so on. As you can see here, some naturals don't have the same even numbers that satisfy the function yet. I need to wait until the naturals come there. Coming back to the original assumption, it's now clear that the bijection is not between the naturals and the even number, but between a restriction of the domain, represented by the even numbers divided by 2, and a restriction of the codomain, represented by the even number. The function between the naturals and the even number is neither a bijection nor a function, because they are elements of the domain that don't have an arrival element inside the codomain, and this doesn't match the definition of a function. Now everything has logic. The cardinality of the natural numbers is not equal to the cardinality of the even numbers. They don't have the same size, exactly as our intuition wants. The even numbers are half of the natural numbers. The key point to understand my logic is to understand that the fact that the infinite of the even numbers is smaller or equal to the infinite of the natural number, not bigger. That's the point. The infinite of the even numbers is limited by the infinite of the natural numbers. I hope I've convinced you about my theory. In a future video I'll explain why naturals, integers and rationals don't have the same size as well. I'll try to convince you using the same entry point. Infinity is the key. Let me know your thoughts in the comments down below, and if you liked this video, thumbs up.